Today's topic is about partial fractions, and when the denominator of the given partial fraction has a repeated quadratic factors, we form the denominators of the corresponding partial fractions as in the case of the repeated linear factors. No? The numerators, of course, are to be linear expressions, so these are linears, and these are the denominators. So we're going to use these partial fractions as we do in the repeated linear partial fractions. So we have this equation here, fraction here, 3x to the fourth minus 13x cubed plus 30x squared minus 36x plus 27, and denominator is x times quantity x squared minus 2x plus 3 quantity squared. So first, after writing this given fraction here, we resolve this into partial fraction and we represent the first partial fractions with the numerator a, and the second one is bx plus c with the second denominator x squared minus 2x plus 3, and the third one is dx plus e over x squared minus 2x plus 3 quantity squared. So after resolving this into variables, we multiply the whole equation by the LCD, which is x times quantity x squared minus 2x plus 3 quantity squared. After doing so, we will get the basic equation. So after multiplying, we get this one. We just copy the numerator of the right side of the equation, this one here. So since this one is x, we have this x here, we will multiply the numerator a by x squared minus 2x plus 3. And this one, since the denominator is x squared plus minus 2x plus 3, we multiply this one, the numerator, by x and x squared minus 2x plus 3. And the third one, since we have here x squared minus 2x plus 3 quantity squared, we just multiply this one, cancel out this one, you just multiply this linear expression by x. So we expand the left side, the right side of the equation. So if we square this one, we just square the 3 times here, x to the fourth, x squared, you just multiply, x squared plus 4x squared plus 9, and then this one we multiply, minus 4x cubed plus 6x squared minus 12x, and we just multiply 2 binomials at a time, plus bx plus c, and then we multiply x to the factor x squared minus 2x plus 3. We get bx plus c minus quantity x cubed minus 2x squared plus 3x, and this one, you just distribute this x here inside the parentheses, we get dx squared plus ex. After doing so, we just combine the similar terms, so we have here x to the fourth and cube minus 4x cubed, the range, in the descending power. So this one is 4x squared plus 6 squared, this time x squared, minus 12x plus 9. Here we multiply also bx by this trinomial here, and c by this trinomial. So we get bx to the fourth minus 2bx cubed plus 3bx squared plus cx cubed minus 2cx squared plus 3cx. And then this one, after multiplying, I'll just copy the terms here, dx squared plus dx. So we have these basic equations here, including the left side of the equation, 3x including this left side of the equation. So we just collect the coefficients of x to the fourth. So we have 3. The coefficients of x to the fourth here is 3. And then the coefficients of a here, of x to the fourth here is a, and this one is plus b. So we have here our equation 1. And then for x cubed, we just collect also the coefficients of x cubed. So we have here negative 13x cubed. Now, negative 13 is equal to the coefficients of x cubed here is negative 4a. So, negative 4a minus 13 minus 2b. No? So this one is minus. No? You just take this one here. Minus 2b. So this one is minus 2b plus c. No? The coefficient of x to the fourth x cubed here is c. No? So that will be our equation 2. For our equation 3, so we collect the coefficients of x squared. So the coefficient of x squared here is 30 is equal to 10a. No? The coefficient of x squared here is 10a plus 3b. No? X squared. Where is plus 3b? This one 3b. No, sorry. So minus 2c, no, the coefficient of x squared here, and d, no, the coefficient of x squared here is d. So we have this equation 3. For our equation 4, no, we collect the coefficient of x. So the coefficient of x is negative 36. No, negative 36 is equal to the coefficient of x here is negative 12a, no? Negative 12 and a, no? And for c, so for c, no? Coefficient of a. So negative 36 minus 12a plus 3c plus e, no? So 3c, no? 3c. So for our constants here, the constant here is 27, not 27, and the constants here is 9a. There's no more constants for b and c and d and f, d and e. So 27 is equal to a, 9a. So therefore a is equal to 3. Now we divide both sides of the equation here is by 9, we get a is equal to 3. After knowing this one, we can substitute this value here to the other equations, beginning with equation 1. The equation 1 is 3 is equal to a plus b. We just copy the equation 1. 3 is equal to a plus b. Since 3 is equal a is equal to 3, we can get the value of b to be 0. So we cancel out b. No? For equation 2, negative 13 is equal to a is 3, negative 4 times 3, minus b, which is 0, c, and negative 13, no, for d, no, 0, no. So, we can get the value of c to be negative 13 is equal to negative 12 plus c, no. So, therefore, c, we transpose 12 here, becomes positive, so c is negative 1. So for equation 3, 30, no, is equal to 10, and then a is equal to 3, minus 2 times negative 1 plus d. No? We can get the value of d to be negative 2. Just manipulate all these numbers here. So for equation 4, after getting the value of a, c, and d, we substitute all the value of a, c, and d to equation 4. So equation 4 is this one, no? Equation 4 is negative 36 minus 12 times 3 plus 3 times negative 1 plus e, no? So after substituting, we get this one. We cancel out 36 and 36 and negative 3, so e is equal to 3. So we now have these values for our unknowns, no? For our variables. A is equal to 3, b is equal to 0, c is negative 1, d is negative 2, and e is 3. We just substitute all these variables here into our partial fractions, the first partial fractions, and we are going to get the values of the partial fractions to be 3, which is the value of a, 3 over x, minus, no? Since b is equal to 0, And c is negative 1, so negative 1 over x squared minus 2x plus 3. And the value of d is negative 2, so negative 2. X minus the value of e is 3, so minus 1 is positive. E is positive 3, so minus 1 is positive 3 over x squared minus 2x plus 3 quantity squared. So that's how we're going to substitute and use the collecting coefficients method. So thank you again for watching our videos for partial fractions when the denominator of the given fractions has the repeated quadratic factors. No? So thank you for watching, and please subscribe to my YouTube channel by Wilfredo Tan. And please comment, no? If you have any comments or suggestions, please say it in English, no? So, because I don't understand any other language except English and Tagalog. So thank you, and see you again later.